So in this lesson we are talking about the second derivative test. So what we want to be able to do by the end of this is to determine if a critical point of a function is a local maximum or a local minimum using the value of the second derivative at that point. And this follows pretty nicely from what we talked about in the previous lesson on concavity. So to recap, the local maxima and minima of a function, f of x, occur at the critical numbers. So if the first derivative is 0 or the first derivative at some value does not exist, then we call that x value a critical number. So I'm just using c here to represent the specific critical number here. And we've asked ourselves the question, how do we know if that critical number, x equals c, is a local maximum, a local minimum, or neither? So in the last unit we used the first derivative test where we set up our interval table and we checked the sign of the first derivative in each of these intervals to look to see whether the curve changed from increasing to decreasing or from decreasing to increasing, or it didn't change, in which case we knew we were looking with something else. If you don't happen to like setting up tables, you could use the second derivative test instead. And the second derivative test uses the concavity of the curve at our particular critical number to figure out whether it's a local maximum or local minimum. So what is the second derivative test? Well, if x equals c is a critical number, okay, we've got three possibilities here. Number one, the second derivative at that value of c could be greater than 0. Okay? i.e. our second derivative is positive. Now if our second derivative is positive, we know that at that point our curve is concave up. That's going to tell us that this minimum, this point here, c, right down there at the bottom, must be a local minimum. So that's our conclusion. So if our second derivative is positive, then f at c is a local minimum. Well, what if our second derivative is not positive? Second possibility is that our second derivative at c could be less than 0. This is telling us that our second derivative is negative. So that means our point c must be a local maximum. So there's our first two possibilities. Second derivative is positive, second derivative is negative. There's a third possibility that our second derivative is not positive, it is not negative, it is in fact equal to 0. If our second derivative is equal to 0, then unfortunately the test doesn't work. And I kind of wish I'd saved the sad face for option number 3 here, because really what option 3 is just telling you is that the second derivative test isn't giving you any useful information about your curve. So you're going to have to figure out some other way of figuring out whether this critical number is a maximum or a minimum. So likely you'd go back and you would do the first derivative test. All right, and that is what the second derivative test is.